sequences and series. We're going to start with the series today. So in an arithmetic sequence, the main difference between a sequence and a series is if there were semicolons, it's called a sequence. But if I start putting pluses and minuses also in between, then it's a series. But it's the same basic concept, all right? There is a technical error in there, but we are not going to split hairs about it. So for this one, they said 6x plus 2, 2x plus 6, x minus 1 is an arithmetic sequence. If they didn't tell me that, I couldn't assume it is. Are you with me? Because they told me that. What is the fact that I know? That there's a constant first difference, the D, which is still linear, still the same thing, but we've got now new formulas coming in with the sequences, a series coming. So, for knowing what x is, I'm saying that there's going to be a constant difference between term 2 and term 1, and it's going to be the same as term 3 minus term 2, which you never wrote specifically like that, and you're also not inclined to have to write that. I like you to write that from now on, because it's going to change soon in a day or two when you're doing the geometric sequences. Because then it's not a constant difference, it's going to be a ratio. So with the constant differences, you're doing exactly what we've been doing all along when we did those other ones starting off the year. We're saying 2x plus 6 minus
6x
minus 1. If you want to still put it in a bracket, like you know. And it's going to be x minus 1 minus, so it's minus 2x minus 6, and we're solving a linear equation to find x. Now let's see.
Dames en heren, jammer voor de plannen en praat specifiek met al die graad 8 onderwijzers, actief onderwijzers en met die graad 8, the grade 8 teachers as well as the grade 8 learners. I'm going to start running the pre-equal set from 2:30 sharp this afternoon.
Okay, let's rectify that. So when you add it, now guys, do you have to have my steps exactly? No. From there, the only next mark you're going to have is for your answer. For manipulation throughout, no marks. Because you could have done just what you wanted to. You could have taken all the x's to one side, numbers to the other side, whatever way you wanted to solve it to get to x is equal to 4. And that's all. They ask you for x and that's that. Now, when you're busy with homework, you can go test and say, if I do substitute the x in there everywhere with a 4, let's see how it looks. And is it truly an arithmetic sequence, just to keep yourself satisfied? But you don't have time for that in an exam. Okay, that's it. How many marks? 2, maybe 3. Okay. Next one was a little bit of a catch. The question says, how many terms are there in this sequence? This sequence looks a little bit freaky, doesn't it?
Yeah.
What's wrong with it?
It's
What's wrong with it? It's every second one is something else. Guys, this is something that they love to ask. November exam, final exam. If I do this, it makes more sense. Can you see it now? What's happening all the time? Now, every second one, the term is 1. So term 1, term 3, term 5, term 7, etc. is always going to be 1. They are joining two separate sequences here, and they love doing that. And when you see that, please use your highlighter pen and show yourself that mine is now black. Yours was like all of them yellow, and the other one is now green. So if I want to know how many terms there are, I will have a look at the green sequence, which you have now green highlighted, and you're going to say the green sequence is 13, 10, 17, etc. Does that minus 53 belong to the green one though? Definitely. If it belonged to the black one, it would have had to be the 1. Oh, thank you. Right. Otherwise, I had a major problem here. It didn't make a sequence. So first of all, I'm going to find out how many terms there are in this arithmetic sequence. Now it looks much better. Because now I can see it's arithmetic in which A is equal to 13 and D minus 3. And guys, this is for sure worth a mark for knowing what the A and the D are, whether you fall off the wagon along the rest of the line. So that's definitely a mark. So how will I know how many terms there are? I need to know which term is negative 53. I need to know which term is negative 53. So I'm asking which term is negative 53. What formula do I need?
The arithmetic.
For the term A plus n minus 1 D, which you get on your formula sheet, and negative 53. So I'm trying to find out the n where I know the A, and I know that you like always, whenever I've got an equation or a formula with various 2 or 3 or 5, I don't know how many variables, if I give you everything except one, you can find it. Because I know A is 13, and I know D is negative 3, and now I can solve for n. Now I know your inclination in general is, let's time all of that out. And that's perfect. Mrs. van Skalkwyk likes to do what? Take the 13 and take it to the other side. Do you have to do my way? No. But negative 13 will give me negative 66. Agreed with me? Still, Mrs. van Skalkwyk is too lazy to time out. I would like to divide by negative 3. And then only n minus 1 is left. So if I divide by negative 3, I do it on that side as well, and I'm getting positive 22. My technique. There are so many alternative techniques. I'm choosing to use that one today. Where you might have chosen to time it out and get the n alone. Are you going to get the same answer as me? Yes. Definitely. But now, what does this mean? How many terms are there?
Not really, right?
Because remember, we were only looking at the green ones.
Now there's ones.
And there's now 23 of the green ones. So how many of the black ones were there?
45.
45 is the answer. Because it's a tricky one in the brain. The first, the third, the fifth, the seventh one is 1, 1, 1, 1, 1. So you tend to think, well, if this one is the 23rd one, then there's got to be 46. Because you chose the second ones. But you're not keeping in mind that the ones are there as well. So is it now? Now this is the classic error. If a child makes a mistake, it's between knowing that it's 46 or 45. And whatever your answer is, making a mistake is going to cost you how much? 1 mark. Are you with me? 1 mark. But is it now 46 or is it 45? Think about it. Because the second and the fourth and the sixth and the whichever one. So this one was actually in position number 46. Because, now, it would have changed if I had given you this sequence. Everything would be perfect, the same up to here. But then you would have thought, okay, well, starting off with the green one, and this being the 23rd one, in between them being a 1, this would have been how many? Not 46, but 45. Are you with me? This would then have been 45, but it wasn't for this particular one. They did start with a 1. So that means if that is term number here, term number 23, there's actually 46 of them. And our common error would have been, some kids would have said 40, most would have said 46. In this case, there would have been a discrepancy. Kids would have said 46 still. And it should have been 45. So then just please answer the question. There are you with me? Confusing you and drawing you out to say 45, 46. Just think about that one little, and if there's a mistake, you're not going to sit there for 15 minutes thinking about it and counting it. If there's a mistake, there's going to be 1 mark. So be it. Now the sequence is in terms of x. Oops, and there's a p popping out there. The question was, prove that p looks like that. So that's your answer. This is where you should finish, by that. It's to prove. So you can't just assume it, but say you couldn't get it right. Then you know that p is that. So can you carry on with the sum, assuming then, I don't know how they got there, but I'm assuming it is. Are you with me? But how would I then prove it? Because the only thing that they told me is that this is an arithmetic sequence. Oops, I was clicking on the chance there. Alright? This is an arithmetic sequence, which means one thing. That there's a constant difference. Doing what?
2 minus 2y equals.
Must be the same as 3 minus 2. And that's all I have. Can't do anything else. 4 minus 3, I don't have it. So then I'm going to know that it's p minus x minus 3. And it's minus 5x plus 3 minus p. Now, if you had not listened to the question or recognized the question, you would have thought, oh, ma'am, this is a mistake in the sum. How can I have two variables in one equation? Normally, if we have two variables in one equation, it's because you're doing simultaneous equations, but where's the other equation? Now, when I read, I hear they say, prove that p equals. So from here, what do I need to do? Take all the p's to one side and prove it's equal. Are you with me? Read the question. Otherwise, this doesn't make any sense. So we have p plus p is 2p. We got minus 5x and plus x is minus 4x. And plus 3 gives me plus 6. And then your p answer would be
Negative 2x plus 3.
what they said. Is this worth a mark? No, because they gave it to you. What's the marks? That you knew that you should be looking at the differences and that you could manipulate to get the p up low. Not for the answer, because they've given you the answer, but if all else fails, you try your best to maybe fool the guy that's marking. Maybe they just see the right answer and they tie it and they give you the mark. Because you should be getting there. Then they say, now, find d in terms of x. Now that I know what p is, I can find d in terms of x. Are you with me? You can rewrite and say x plus 3, then minus 2x plus 3, then minus 5x plus 3. Because now your p is now been substituted here. Are you with me? Yes. How would your d then look? This would be your d. Minus 2x plus 3 minus x minus 3, which gives me minus 3x, and that's it. Because that falls away at 0. Are you with me? But that's not the only option, because where else is d? This is d.
Yeah.
Right? But you now know that p must be substituted with minus 2x plus 3, and you'd still get to minus 3x. This is also d. Right? If you want to substitute the p there, inside there, you'll still get to d is equal to. But maybe that's a little bit lots of confusing stuff. If you rewrote it, look at the d and find it in terms of x. That was what the question was. It's just my own abbreviations. Find d in terms of x. So there's my d. So now that I know d, they say, if I now tell you that, and they didn't write it nicely in math like that, they said it in English. If the 22nd term is 127, write it in maths. The 22nd term is 127. Do you see it? You're rewriting it from English language into math language. But then now remember, with sequences and series, we've only got the one formula so far, but we're going to have a few. So you're always going to search for which formula am I going to use. There's only one formula that you know so far, and that is the term formula. So what is term 22 then going to be? If Tn is, right? What was the shortcut I taught you? So if term 17 would then be A plus? Excellent. Are you with me?
Yes.
N minus 1. So that means that if I'm talking about term 22, you're going to immediately write A plus, and you got a mark. For what? for using the correct formula. Without showing the formula, substituting and then simplifying, you've got a mark for knowing the formula. And now how's that going to help me to find x? Since I now know that, do I know a?
Yes.
What's a?
X plus A.
Excellent. I never wrote it, but there will be a mark for knowing a was the first term. Going back here, a was the first term. Then D, I'm not going to find out again what D was. I already did it. I did lots of work here. So I can just go substitute the D with. And because it's been given equal to 127, I now know I can solve for x. Alright. Simpler alternative techniques. Your next mark will be for your answer. Alright. I think, guys, just check up on me. And it doesn't have to be a whole number. I don't have to have a whole number. Are you with me? This is not in. If it was in, it had to be a positive whole number. Okay. X could have been a fraction. It's fine. Done with the sum. Happy on that? Okay. We have one more to mark. Right. You're going to start looking for them and immediately seeing them. Don't forget that you still have a quadratic number pattern as well. Could one of them, the black one or the green one, could that have been a quadratic one? Okay, so it can be linear or quadratic, and it's still going to come geometric as well. But there's a combination. This was, again, a nice easy one with the 1 everywhere. So tell me, what is term number 20 going to be?
You're gonna have to
Easy? Which is the nice one? Which is going to be 1?
21.
21. Yes. Without showing anything, because it's a logical deduction. First position, third, fifth, 21st position would be 1. No calculations necessary. But then for the green one, my A is 2, my D is 3, guys. Wakey, wakey. And now I want to know which term this is that I'm looking for.
Term 3.
The 20th term. Is which term in the green one? So the 20th term is term 10 in the green sequence. Guys, are you following? Right, so that would then be, quick shortcut, term formula A plus term 10, 9D, where you know that A is 2 and that your D is 3 and the answer is 29. Done. You with me? Okay. Yes, it was just term 21, maybe highlight it. And then, did I answer that question actually? Oh, I would have been happy because you said here this 20th term would be the 10th term in the green one. Unless you want to at the bottom also say. So, therefore the term 20 in the original sequence would have been 20.